Welcome to Machine Learning Algorithms Demystified, where we'll explore the fascinating world of how computers learn and make intelligent decisions. At its core, machine learning is about enabling systems to learn from data, identify patterns, and make predictions or decisions with minimal human intervention. Think of it as teaching a computer to recognize a cat by showing it thousands of cat pictures, rather than explicitly programming every single feature of a cat. This learning process is powered by various algorithms, each designed for specific tasks and types of data. One of the most common categories is supervised learning, where the algorithm learns from labeled data, meaning each input has a corresponding correct output. Imagine training a system to distinguish between spam and legitimate emails. You provide it with many examples of both, clearly marked. This type of learning is used for tasks like classification, where the output is a category, or regression, where the output is a continuous value, like predicting house prices. Unsupervised learning, on the other hand, deals with unlabeled data, finding hidden patterns or structures without prior knowledge of the outcomes. A prime example is customer segmentation, where an algorithm groups customers based on their purchasing behavior without being told what those groups should be. Then there's reinforcement learning, where an agent learns to make decisions by performing actions in an environment and receiving rewards or penalties. This is how AI learns to play complex games or control autonomous vehicles, continuously optimizing its strategy through trial and error. Regardless of the type, all machine learning relies heavily on data. The quality and quantity of data directly impact the algorithm's performance. Features are the individual measurable properties or characteristics of the phenomenon being observed, like the size, color, or price of a house. These features are fed into the chosen algorithm, which then builds a model. A model is essentially the learned representation of the patterns within the data, allowing it to make predictions on new, unseen data. The training process involves feeding the algorithm data, letting it make predictions, and then adjusting its internal parameters based on how accurate those predictions were. This iterative refinement continues until the model achieves a satisfactory level of accuracy. Evaluating a model's performance is crucial, using metrics like accuracy, precision, and recall to understand its effectiveness. Some popular algorithms include linear regression for predicting continuous values and decision trees for making classification decisions based on a series of rules. Support vector machines are powerful for classification by finding the optimal boundary between different classes of data. And then there are neural networks inspired by the human brain, capable of learning highly complex patterns and forming the backbone of deep learning. Machine learning algorithms are transforming industries, from healthcare, where they assist in disease diagnosis, to finance, by detecting fraudulent transactions. They power recommendation systems on streaming platforms and enable autonomous vehicles to navigate our roads safely. The benefits are immense, offering unprecedented efficiency, accuracy, and the ability to extract valuable insights from vast amounts of data. However, challenges remain, such as ensuring data privacy, mitigating algorithmic bias, and making complex models more interpretable. For beginners, starting with foundational concepts and experimenting with open-source tools and datasets is a great way to dive in. The future of machine learning is bright, promising even more innovative applications that will continue to shape our world. We hope this overview has demystified machine learning algorithms for you, inspiring you to explore this exciting field further.